Hi, this is Mrs. Clark, and this is going to be a video about solving systems by substitution, but this is going to be the type 2 version of substitution. So when we're looking at this example, it's type 2 because this first equation is in standard form, where the x and y are on the same side, or it's almost in standard form. And the second equation is y equals mx plus b, or slope-intercept form. So type 1 had both equations in this form, slope-intercept form, but type 2, we've got one equation in a different form. But the idea is still the same, so we're going to use a very similar method, just the beginning part is a little bit different. So let's write down the steps, and as we write down the steps, we will follow the example. So our first step is to figure out which equation to use first. So first thing we do is find the equation that's either equal to x or equal to y. Find the equation equal to x or y. So that's the first part of step 1. So this one says equal to y, so I'm going to use this one. So the first thing I'm going to do is choose the one I'm going to use. I'm going to use this one. Then the second part of the step is to and substitute, which is why it's called substitution, it into the other equation. So this 2x minus 3 is equal to y, which means I can replace the y in the first equation with it. So this 2x minus 3 is going to go in place of that y. So first thing I'm going to do is rewrite the 4y plus 6x equals 2 equation, but I'm going to replace the y with 2x minus 3. So 4 parentheses 2x minus 3 plus 6 equals 2. So all I did is replace the y with 2x minus 3. Step 2 is to solve the equation to get the value of the first variable. Solve the equation to get the value of the first variable. So if I look at my equation, it only has the variable x at this point. So I'm going to solve this equation for x, and x will be my first variable, will be the first part of my solution. I'm going to also need to find y, just like we did before. So to solve this equation, I have parentheses. So in order to get rid of those parentheses, I need to use the distributive property. So 4 times 2x will give me 8x. 4 times negative 3 will be negative 12. And I'll bring down the plus 6x equals 2. So to continue to solve, if I notice where my equal sign is way over here on the right. So on the left I have 3 terms, and 2 of them have x's. So I'm going to combine my like terms together. I've got 8x and plus 6x, so both positive. 8 plus 6 is 14. 14x minus 12 equals 2. I don't use inverse operations here because they're on the same side of the equal sign. To continue to solve, I'm trying to get the x by itself. So I'm going to get rid of this minus 12 and do the inverse, add 12 on both sides. So those will cancel out. I'll have 14x over here equals 2 plus 12, which is 14. So to get x by itself or isolate the variable, I need to get rid of this 14, so I need to divide it out. If it's in front of the x will equal 14 divided by 14, which is 1. So the first part of my solution is 1. I need to know what y is also. So that's the next step. The next step is to figure out y, substitute that value, the one I just got, which is x equals 1. Substitute that value into one of the original equations and solve. So I can use either equation, But if you notice, one of them is going to be a lot easier to solve for y. So the second equation says y equals, which means when I put an x in here, I'm just going to calculate 2 times the x minus 1, and that will give me y. I can use the first equation, but because the y has so many other things on the same side of the equation as it, and there's also a 4 in front of it, it's going to take me more steps to solve. It doesn't mean I can't do it, it's just not going to be as quick. So I'm going to choose to use y equals 2x minus 3. You can always do it in both to check to see if you're right. So I'm going to take the x equals 1, and I'm going to put it into this second equation so I can figure out y. So y equals 2, replace the x with 1, minus 3. Now I'm going to calculate this. Y equals 2 times 1, which is 2, minus 3. 2 minus 3 is negative 1, so y equals negative 1. So I have my solution. The last part we just did is to write the values as an ordered pair x comma y and check. Now you've probably noticed with substitution that it's really easy to go wrong, to make a mistake with a negative somewhere, to get the wrong x, then you're plugging the wrong x into the other equations to getting out the wrong y. So checking is a really important step just to assure that you didn't make a mistake. If you did make a mistake, you can go back and look for it. But the way I check is I'm going to plug these x and y's into both equations just to make sure they both come out true. So I'm going to do that down here at the bottom just to show you. The first equation I'm going to do is the 4y plus 6x equals 2 equation. Then I'm going to check it in y equals 2x minus 3. So I'm checking to see if both sides of the equal sign equal out to the same number when I do this. So here, 4 parentheses y was negative 1 plus 6 parentheses x is 1 equals 2. So I'm looking to see if 4 times negative 1 plus 6 times 1 equals 2. 4 times negative 1 is negative 4 plus 6 times 1, which is 6. Negative 4 plus 6 is 2. The other side also says 2. 2 equals 2 is a true statement, so I know the solution works in that equation. Now I'm going to try the other one. If it works in both, then I know I'm correct. For y, I'm going to put negative 1. We're going to look to see if that is equal to 2 times 1 minus 3. Negative 1 equals 2 times 1 is 2 minus 3. Negative 1 equals 2 minus 3, which is negative 1. And again, both sides are the same, so I know that my solution is correct. Since it checked out in both equations, it is the solution, the one point that the two equations share. So I hope that was helpful. Put this into your notebook. Again, Solving Systems by Substitution Type 2. Put this into your notebook and then look for the video on Solving Systems by Substitution Type 2, where we'll do 4 examples together, and then you'll be able to do some independent practice using this method. Thanks for watching.